Hello ladies and gentlemen, my name is Decryption and I hope you are well. It's been a long time coming and we've had a lot of requests, so we're going to carry on with the NPC spawner system we're recreating from San Andreas. And in today's episode, we're going to look at placing where we want them to spawn. We're going to use a good EQS system to pick an area that meets all of our criteria, and then we're going to use it in our system to make the spawning look really nice. So let's get started. So here is the design that we've been using all along to plan how we're going to make it work. And we have finally arrived at the point where we need to make sure the NPCs don't spawn in our set field of view. So we don't want them to spawn in a rough circle around us, because that's just going to look very jarring when they appear in front of you. But equally, we don't want them to spawn in the player's view cone, because then it's just going to look really glitchy and it won't be very good. Upon that, in case the player moves side to side fairly rapidly, we don't want them to spawn on the edges of the view cone either. So we want to make sure that within the player's viewport, something like this, we don't spawn anyone. We want to make sure that we spawn it out of the distance if they're far enough away, or if they're behind buildings, then they get an automatic pass, or if they are, of course, behind the player. One of the examples we used is if we were walking up this street here, we'd want to spawn them around this corner and around these buildings if they're allowed to be there, so that it looks like the player is going around and life is living in the world. So we could just do a bunch of branches to make this work, say. So we get a random point, we see if it meets the player's viewport, if they're behind a building, if they can spawn there, blah, blah, blah. But that can become really complicated, and it's not highly performant. So we're going to use something called EQS, Unreal's Entity Query System. It's actually super easy to use, and it's just thinking about the logic you want to get it to work. Now, we could improve our system that I've planned to do a little bit further ahead by doing some custom C++ tasks, which will allow us to do special things, like where we say, don't spawn anyone here unless they're behind a building as well. But I figured a way to do it without any C++. So if you'd like us to go for that C++ version, let me know and we'll add it in a future task, but it will be optional. So here is where we are so far. We have a big map, and as we click play, you'll see the NPCs will start to spawn in like so. The shaders are going to compile, but they are going to spawn in. If we look forward long enough, they will kind of actually spawn in front of us eventually. And we will see pop-in, which is what we want to avoid, which is why we're doing this cool system. So in order to test this system more before we do jump into it, I am just going to come and add a couple of cubes in, just so we can really test the EQS system and make sure that if they are behind a building, they're still going to spawn. So I'm just going to place these like so. So you can see we've got plenty of places where they can spawn around the player. And of course, depending on your camera system, so if it's top down or whatever, you may have to modify this to work. But for me, mine's a third person game. So like right now, if they spawned around there, I'd have no idea about it, which is good because as soon as I turn the corner, bam, people. So it'll look really cool. So how do we use Unreal's EQS system? It's super easy. If you watched our hide and seek tutorial, you've already had a good glimpse into roughly what we're going to do. But if not, that's totally okay. So I'm just going to come into my AI folder, and I've already created one called EQS. And then I'm going to right click, Artificial Intelligence Environment Query. And I'll call this EQ underscore find NPC spawn location. And I'm going to open it up. So if you've never used EQS before, it's super simple. It kind of just looks at behavior trees. All you do is drag down off of here and add how you want it to actually spawn, so how you want it to run the checks. Now, you could do a basic grid like so. So if I just save that like so, jump back into our world, I can drag this EQ into the world as a test, and you'll see it's spawned a grid. If it's all blue, it just means they're 100% okay. We can use it in the logic we want. But the benefit and power of EQS is as I move it, or I change where it's spawning, it will automatically skip over things and we can add tests to it. So we can test each one of these nodes under a condition. So for example, we very well could come in, right click, add a test, and we'll say distance. So we'll say it's got to be, we'll select the distance, and then we can say the maximum range has got to be 500. And it can't be less than 100. And we will save it. And you'll see it's going to say distance from blank to the querier. So the querier is the actor who's running the EQS query. So in the drag thing that we've done, it's this little testing pawn here that's built in. But you can see now we've got a bunch of colours and numbers. So because we've set ours to say a distance of between 100 and 500, and it prefers greater, it's going to rank anything that's far away a higher number than it is when it's closer. So you can see if it's in the middle, distance of 0, that is below 100. So that's marked as a distance of 0. It's blue, it's cancelled out. Likewise, all of this here is more than 500. So you can see, if I put it in the middle, we've got a nice circle shape from where it's testing it. And all of these blue nodes have been cancelled because they're not meeting our criteria. All of the green nodes are the perfect ones, and as it gets closer to the player, the score goes down. Equally, if you wanted to reverse it, you could come in, change the scoring equation from linear to inverse linear, so it goes prefer lesser, and you can see we've now got the opposite. So closer to the player is better, further away is wrong. So you could use that for something like combat, where somebody with melee weapons needs to run up close, as when they get this area, that's where they attack. Flip it around, do the linear one, that's where ranged attacks can work. But how are we going to use this for hours? So if you remember, we've got a bunch of criteria here that we need to match. But it's actually really simple. So the first thing I'm going to do is these nodes here, we're going to want NPCs to spawn at a decent distance. We're not going to set it to something stupid. So if I click my simple grid and just set the half size to something like 50,000, we're going to get a lot of nodes. Look. And it's lagging my computer. We don't need that. That's insane. See, it's so insane it crashed. That's the thing. So we don't need that many nodes. Because if you will check every single one of these to find if they need to spawn, it's going to take forever and it's not going to be very good. So what we're going to do instead is limit how many nodes are there, and we'll just randomize it a little bit. But you can see there's a lot of nodes here, and there's more blue ones, meaning we shouldn't use it, than there is live ones. So as I said, remove the simple grid, and instead what I'm going to do is I'm actually going to come and use a donut shape. And you'll see if we keep it at 300 to 1000 and reselect our EQ here, you can see it just randomly places them in a donut shape. If I move it out to somewhere clear, like so, it's like that. And it gives us a really good broad area, but it ignores all of these little nooks and crannies here, which is perfect for us, I think, because it gives us the ability to just do little things like this. So if I come into here, I'm going to come and set the inner radius to 800, so a bigger radius around the player, and the outer radius I'm going to set to 5,000. Now it'll sound like a lot, like we've used a minute ago, but don't forget it's very broad, as you can see. So at the moment, we're going to spawn NPCs all the way over here, which could work for the player as he's walking through. But I think we need a few more nodes than the odd ones we've got here. So we'll come back to the EQ, and on here, I'm going to set the number of rings from 3 to 6, so it's doubled, and points per ring to 16. And you can see we've got a lot more nodes now and a lot more areas to spawn an NPC. So the first thing we're going to do is we're going to add a distance test to it, just like we did. So we can right click and we can do add test distance. For the distance, I'm going to keep it as filter and score. Filter basically means it will remove the node entirely and say you can't use this. Score is what gives it the number. So if they're really far away from the player, but we've got no other choice, for example, say we're in a really long corridor, then we probably want to keep it there as a backup for somewhere to spawn. For the range, I'm going to set it to the radius of the actual donut shape. So I'll set it to 800 and 5,000. And it's going to prefer greater, which is perfect because we don't want it spawning right next to the player. So you can see now, it's going to less likely spawn them here, but it'll be more than happily to spawn them all the way over here. So not somewhere where the player is going to easily see, but equally, it's spread around enough that they're not going to pop in right next to them. Next, you can see we've got a few spawning in areas that you physically can't get to. So, for example, they're outside of the nav mesh or something. We want to avoid that because we're in a busy city, like on our document, we don't want them spawning in the middle of buildings. So back on our EQS, I'm going to add another test to it of pathfinding. And it's just going to say it's going to remove anything that's unreachable, basically making them only spawn in available areas. So you can see now here, it's completely ruled this one out because of pathfinding. And it's also ruled off the 3 in here because you physically can't get to it. And because of how Unreal's nav mesh generation works, it's got stuff, which is perfect because if you have a locked door or something, it won't spawn an enemy behind it, or an NPC behind it. So we're looking good so far. The next thing we're going to do is we want to remove anything that's in the player's viewport. So at the moment, this player is viewing that way because of the arrow on the floor. If we rotate him a little bit, so he's facing that way, we don't want to spawn right here because the player can easily see it. But equally, we do want to spawn them behind here like so. Now, one of the things that I was mentioning earlier with the C++ trait is we could just run a trace from here to each node, which is built into EQS, and say, can the player see you? Yes or no, spawn it. But the problem is we want to spawn behind the player, which means all of these, if we did a trace, would flag up as false because the player can trace it, and that's not what we want. So for this, we'd have to make a custom test, but that can only be done in C++ at the moment, which is an unfortunate side. So if you did want us to look at doing that part to add some more realism to it, let me know in the comments below. We can have a look at that in a separate video. But for now, what we're going to do instead is actually just tell it, instead of filtering it out if it's in front of the player or if the trace hits it, we're simply going to add a score to it instead. We're going to score it if it's in front of the player and if the trace hits it. So we're not going to entirely rule it out. So what I mean by that is these 5 here in front should be disqualified because the player can see it. We know that. But these ones over here are also in front of the player if we just use the dot product. So all of them will be disqualified as well. That's not what we want because we know we can spawn around here without the player seeing it, which is where we're going to pair it up with a trace. So instead of these ones being disqualified, we're going to give them a negative score. So as you remember I said, higher scores means that they're more likely the ones we want to use. So a lower score, if we give it a negative score with the dot product because it's in front, all of these will get a negative score. But then when we do the trace, we'll give it a positive score because these here will be hit with the trace, so we'll ignore them. But these ones will be blocked, so they'll get a positive trace boost. And it's a way we can kind of glitch it together. In C++, obviously, we'd combine this together and make it work really well, but that's fine. So, how do we do this? So, I'm going to come to my EQ here, and the first thing I'm going to add is another test of dot product. Dot product basically gets us a number between -1 and 1, depending where it is around the player. So in front of the player, we'll get a number, so you can see everything's gone at the moment. But behind the player, or to the sides, we can get specific numbers to say, in the rotation of the player, where do you sit between -1 and 1? So on the dot product here, we want to use the querier's rotation, so the person who is running the EQS, where are they rotated? We want to run a trace between 2 points, so the querier and the item. The item is each point, so it's going to go line trace, line trace, line trace, line trace, line trace, but across every single node. But it's built to do it really quickly, but that's also why we're not using the big grid one. And as I said before, we don't want to rule them out, so we're just going to set it to a score, and you can see it's disappeared there. But in the clamping, we're going to set both to a specified value, and for the minimum, we're going to set it to -1, which means it should be behind the player. And the maximum, we'll say about 0.25. And what that's going to do, as you can see, you can basically see the 0.25 effect here, behind the player being giving a negative score here. So you can see we've got a negative score back here. So you can almost see the 0.25 there, just that small little cone. And everything in front has been given a higher score. But that's backwards to what we need. So you can see it says prefer greater. We actually want the opposite. So I'm going to come and set the scoring equation to inverse, just like we discussed at the beginning, to flip it around. And now you can see everything slightly to the right and left and behind have got higher scores than everything in front, which has been given a lower score, which is the part of what we're working with. But you'll see the ones behind here have also been given a lower score, but they're okay to be spawned, which is where we come into the secondary one, where we're going to add a trace test. So we just want another scoring one, and we're just going to do a standard line trace. And you'll see this time, all of these have now been bumped up on scores again because the line trace is blocking them. But these ones here are still being scored quite high. So what I found to counteract this is that we can actually come into each of these dot and trace, and we can just change their scoring factor to a multiple of 2. And what you'll see is it's basically now halved the bars on here and say, you two matter, but only half as much. The dot product and the trace have double the say, if you will, which means their scores are all duplicated. So you can see these are all scored really poorly now because they are directly in front of the player. So they are going to get immediately ignored, if you wish. Everything behind here has been scored quite highly, and everything behind is scored even better. So what we'll do in our code is we will basically say, remove anything that's under 2. So all of these red ones here will be removed, but everything else will be allowed in. And then we can randomly pick one and say, you will accept my NPC spawn. So I hope you can now see it starting to come together. And it does look really cool when the numbers are all glowing. But you'll see as we move it around, we will get different figures. So around here, look, it's saying don't spawn it here because the player's going to see it in their view cone. And because of the numbers we've set with 0.25 being such a thin margin, even if the player's looking forwards here, all that's going to be blocked. And if they move sideways, that's blocked too. Which means if they walk like that, like they do in Portal, even that one, look, is blocked. They would have to do a full 360 in order to see a spawn, but a spawn's only going to be a single frame. So that's why it's going to be really cool. And of course, if you wanted more nodes, say if you've got a really intricate city system, you can add more nodes or more rings per node. You could even play with different shapes. But for me, this one's okay. So now, how do we add this into our spawner system to actually make it start using this? So running an EQS is actually really simple, but the tricky part is you have to tell it to wait for it to run. Because as you can imagine, all of these nodes here, it's not going to query them all instantaneously with no delay. There's going to be a slight delay, but that's okay because it's built to work asynchronously, so it's not going to lag your game. Of course, if you put the 50,000 nodes in, that might lag your game, or at least postpone what needs to happen. So we basically need to tell it to run the EQS query, wait for it to finish, which for our small example here will be a very minute amount, pick a node and then run with it. We could just say pick the highest node, but then it's always going to pick the furthest away one. It will look really weird for the player to be in a dead zone. They'll wander around, oh, a person. They'll wander around, oh, another person. So we are just going to randomize between all of these nodes here that are acceptable. I'm going to come and open my NPC spawner. And we have a function called get NPC spawn location. That at the moment, all it does is just get a random reachable point. But we're going to upgrade this. So what I'm going to do is I'm going to delete the random point reachable point. I'm going to move this down. Now I'm going to drag off of this and I'm going to do run EQS query. The query template we want is going to be our find NPC spawn location. The querier is going to be our player because we want them to spawn around the player. The run mode is we don't want it to get the single best actor. That's where it just finds the highest number, randomly picks one, which will probably be that 501, 503, and 553, and pick that one. We don't want that. We want more control. So I'm actually going to say, return all matching ones. And the wrapper class I'll just set to EQS query, just so it knows what to wrap this output in as a class. Then I'm going to drag off of this and I'm going to do bind on query finished. You'll notice you won't be able to do assign, and that's okay because we're in a function. So I'm going to drag off the event and just do create event, and then click the function and click create a matching function. And I will rename this to get NPC spawn location results. And you'll see it's automatically put the 2 inputs in. Back on our get NPC spawn location, I'm just going to connect this to the return, and I'm going to remove the output. It may complain because we were using the output, but that's okay for now. You'll notice we can't compile, but again, that's okay. So get NPC spawn results here. I'm going to drag off of the query status and do equals equals, and I'll do the enum, and I'll just make sure it's a success. So I'll connect it to a branch. If it's not a success, it means it's failed to do it for some reason. So I'm going to print string failed to find NPC spawn. So if it says that, we need to figure out what's wrong with it. Chances are you've probably put the player, or you've not put an NPC path somewhere. So you can see when I put it all out of there, every single one fails to get to the player. So that will probably return false. So that's something we can look at. So as long as it succeeds, we're going to right click and do get query instance, which is just this variable right here. And then from here, I'm going to do get query results as location. And that's going to get us every single node that has passed and their world locations in our world. But now we need to loop over them and remove any ones that we don't want, like these ones here. Because whilst they're still available, we know we don't want them. So back on here, I'm going to loop over the locations with a for each loop. But before we do that, I am just going to add another branch here, just to the return value. So just in case it succeeds, but nothing passes, I'm going to just put another error message in, which I'll just put number 2 on so we know which one it is. And then we're going to start looping over all the locations. But in order to get the scores, I'm going to get the query instance and drag off it and do get score, like so. I will pass in the array index to it, and as it loops over every single node here, it will get us the score. So 1.16, blah, 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 and then 2.69. So what I'm going to do is basically say, remove anything that's below 2. Because everything here, which is acceptable to me, is at least above 2. So I will say, if it's below, I'm going to add a branch to it, and then I'm going to promote the array element to a local variable, and then delete it. I will rename this to accepted locations, and I'll right click the vector to make it an array. I can then drag this back out, do a add, and connect this to the false. Because if it's true, we're going to ignore it entirely because it's below 2. If it's false, it means it's above 2, so we can get the accepted location. Finally, on completed, once it's run over everything, I will get the accepted locations, I will find a random array item, and then I'm going to promote this to a variable, a normal one, chosen NPC location. I will make this private, and I'll connect it up to the completed like so. The reason we're doing it this way is since this function is a delayed function, meaning whenever anything calls get NPC spawn location, it will have to wait until this succeeds before it can carry on. So if we come and select our random locations here, right here you can see it's trying to spawn the actor to get their location. Equally, our second one is doing it when it gets the NPC from the pool. So we've got 2 nodes. We've got the one where we get the pool, and then we've got the one where we spawn a new character. So we need to take care of both instances. So to do this, I'm going to go into the get NPC spawn location, and I'm going to make it a not pure function like so. And I'm going to go back to my event graph, and just before we start checking anything, after we've done an async call here for the spawning logic, I'm going to simply come and call our get NPC spawn location like so. And I'm going to disconnect it from here. And then I'm going to come and add another custom event down here called EQS location found. And then I'm going to move basically all of this down into this function. So where they're connected to the current spawn profile here, I'm just going to back off and do get current spawn profile. And I'll do the same down here just to disconnect it, like so. So they're now isolated away. I'll make some space down below. And then all of this logic over here, I'm just going to basically move down here like so. And we can connect it up Instead of using get NPC spawn location, I'm going to use the chosen NPC location we've already got from this function up here. And then if we hit compile this time, you'll see we've only got one more error. So if I click this one, this code here is doing the same thing, but we know we can just apply the variable like so. And there we go. So if I hit compile now the final thing is our get NPC spawn location results. After it's picked one, we simply need to tell it to call our new EQS location found function like so. So I know that was a little bit jarring, but to run over it again, on begin play, we start the timer, we let the timer run, and every 3 seconds we check if we should spawn an NPC. We check the NPC distances to make sure if we should despawn them, add them to the pool, sort them out. We then check in our macro, should we spawn the NPC? Have we filled up the max gaps? Something like that. We then call randomly get NPC, which finds us an NPC in the territory that we're in. And we set the spawn profile, and then we say find a spawn location. That's going to run our EQS query here to find an available location, and it will mark that one location. After it's done that, it will come to our get results, where it will take the instance, it will loop over it, removing anything we don't want, randomly pick one, and then call our new location found. Inside here, it will then pick whether or not we need to use the pool. If we do, it will use the pool and use our set location. Otherwise, it will come down here, spawn a new character, and then wait for the timer. And then the next 2 seconds, it will come back in and run it again. But one thing you'll notice when we run it, apart from the bug that I have that I need to fix where it's spawning invisible characters, you'll notice that they're spawning directly on me. And what's that all about? That's ignoring our EQS entirely. And this is down to something, one of them quirks of Unreal, is when you use get item score, it actually normalizes the value versus the testing pawn that you drag in. So what we need to do, if we want it below 0.2, is we need the normalized value instead. So instead I'm going to do 0.4. So just something vague. I think the technical version is like 0.385 or something, based on the scores we have or can have. But that should hopefully now resolve it so we don't have an empty EQS. And just wait, you'll see that it's no longer spawning directly on us, but you can see in the part over in the outliner, we are indeed spawning them. So if I press F8 and look around, you can see it is indeed spawning them. But we've got a small conflict where it's spawning them a little bit far away, meaning our check code is deleting them because they're too far away. But you can see they are indeed spawning outside of the player's viewport. So the first thing I'm going to do just to ease this is back on our check NPC distance, where we're checking if the NPC is just simply too far away. I'm just going to bump that up by 3,000. So they have to be further away. But on our EQS, I'm actually going to come and reduce the size of it from 5,000 to about 3,000. And I'll make sure you do the same on the distance, otherwise you'll get inconsistent. You'll see now that our EQS is a lot smaller, but in a city that's still completely open. Just to test it a little bit more to make our testing easier, I am going to come and change the timer to something like every 2 seconds. So it's quicker. And I'm also going to upgrade the amount of NPCs we can have from 4 to 12. This isn't anything you have to do. This is just so we can see it easier in testing. But you'll see now, we can't see any NPCs. And you will see that if I run it now, and we give it a couple of seconds to spawn things, you can see as we look around, the NPCs are there, but they're not popping in front of us. So if we just look over here, you can see he spawned out of nowhere and he was behind us. But if we press F8 and zoom out, you can see all these NPCs have spawned, but because we're facing forwardsly, we can't see them, which means it's going to look really nicely in the game now. So if you imagine running around a big island, you're not going to see these NPCs spawn in front of you. Of course, if you want set spawns, like a bandit camp and stuff, this isn't for you. This is more for random NPCs around the world. So, for example, in my map, at least the current iteration of it, I would place the spawner probably somewhere in this world, and then it would spawn around all these nooks and crannies. So you can see as I'm stood here, it's not going to spawn in any of this because it's got buildings there, but it's going to spawn around it. So as I move around the world, it is indeed going to spawn randomly around the map, adding life to the game. I also don't know why I'm getting such low FPS at the moment. But that is the EQS system required for our NPC spawner. So you can see it is indeed coming along very nicely now. As I run through here, the NPCs, unless we get unlucky, they are going to spawn behind us, to the edge of us. We shouldn't see popping. As you can see, he was around the corner. This is what I mean. It's so cool. So as I run down here on my 20 FPS for whatever reason, as I run around, the NPCs shouldn't spawn in front of us. Look, that's it. That is how cool it is. She walked around the corner. How cool is that, ladies and gentlemen? My low FPS, I think that's something to do with my computer. That's nothing to do with what we've done today, I will say that. But yes, there we go. There is our EQS spawning system. You can, of course, completely boost this. If you do want the C++ version, please let me know. And that's where we combine the dot and the trace ourselves instead of using two, where we realistically say these here will be outright rejected. They won't even be considered. So it gets a minor speed boost, but these ones over here will indeed get a normal score. So instead of having to do the loop over them all, we will just outright remove them if they're too low. Have you got any improvements to this that you changed? What other tests would you add to make it more realistic? In the next tutorial, we're going to look at location-based spawning. So that is on our map, in a general area here, is completely fine. But if we come into the purple gangs or the knights, Egyptians, they will switch the profiles over and only spawn that. It's going to be a really nice tutorial where we're going to run into different areas and watch the NPCs gradually change over to different NPC types and profiles. So we're definitely coming along very nicely now. The NPC system is going to be really nice to just add into the world, and it will follow the player everywhere they go. Thank you for watching. I hope this helped. If you've got any improvements, please let me know below. My name is Decryption, and I will see you next time.